Today we will be doing lesson 4, using special triangles to determine exact values. Take a second to read through those learning goals there so you're ready to go and you know what you're doing today. So to begin, we're going to look at being able to find our primary trig ratios. So remember SOHCAHTOA or sine, cosine, and tan for any angle by using a point PXY on our terminal arm. So here in this diagram, you can see our point P. Because you're on your x-axis, we're going to label this side of our triangle x, and then when you go up, you're parallel to that y-axis, so you're going to label this side y. You have something labeled as an r right now, and it's because you're in a circle with a radius, so we're just denoting it as an r, and we're able to express that point P as a function of theta. So in other words, you just have three sides. They're going to be labeled x, y, and r. And once we get into an example, this won't be x and y anymore. It'll actually be a numerical value. So to be able to find that length of our radius, we have our Pythagorean theorem. So it's the square root of x squared plus y squared. You should know that. And then we're also able to set up our three primary trig ratios, so sine, cos, and tan. For our sine, we have opposite over hypotenuse, so you're just going to look over at your triangle here. So your opposite would be here, your adjacent is going to be here, and your hypotenuse is here. So you can fill out those values. So your sine of theta is going to be y all over r. Your adjacent is going to be x all over r. And your tan is going to be opposite all over adjacent, so y over x. So we're going to actually get into a couple of examples where this will make more sense, but essentially we're going to use those primary trig ratios to help us answer some questions. So for example 1, we're going to have a point P3, (-4) is on the terminal arm of an angle in standard position. So remember, standard position is at the vertex, and on our x-axis, that terminal or that initial arm has to be on that x-axis. Sorry. So it asks us what are the values of the primary trigonometric functions, and also what is the measure of the principal angle theta to the nearest degree. So let's take a look at A first. What are the values of the primary trig functions? So it would be pretty hard to picture this and do this without a diagram or a sketch. So let's draw it first. So if you had started at your 0, where you're in standard position, you're going to go 1, 2, 3, and then 1, 2, 3, -4. So then you have that point P3, -4 on your sketch. Okay, remember that this terminal arm is going to be your radius. And then you're able to set up the rest of your triangle as well. So if you were to actually just draw your triangle, your x is 3, your y is 4, and then you are going to, your y is -4, and then you're going to be able to find your radius as well by using your Pythagorean theorem. So you know that your x is 3, your y is -4, then your r, you're going to do your Pythagorean theorem. So you have your x squared, which is 3 squared, plus that -4 squared, which is your y. 3 squared is 9, plus -4 squared is positive 16. Remember, it's in brackets. 9 plus 16 is 25, so you're going to square root 25 to get 5. So that you're going to know that this is 5 for your r in your diagram now. So from our previous slide, we know that sine theta is equal to y over r, cos theta equals x over r, and tan theta equals y over x. So you're just going to go and look at that now. So remember that this is your x, this is your y, this is your r. So opposite all over hypotenuse, so you're going to get -4 all over 5. Your cosine is going to be adjacent, so your 3 all over 5 already came up there, and then your tan is y over x, so you're going to go opposite all over adjacent there, so -4 all over 3. For that second question, what is the measure of the principal angle theta to the nearest degree? So a little trick for this is that to evaluate this, this angle theta, we can select any of those primary trig ratios. So let's just select sine. It's our first one. So we're going to take sine of -4/5. I hope that you remember how to solve this. You need to take that inverse. That's why we did our review at the beginning. So you're going to get the sine inverse is -4/5, and that should become approximately -53 degrees. However, does this angle theta with this pink arrow look like -53 degrees? No, it does not. So it's actually our related acute angle. So a little trick here. So this is actually our -53 degrees. And so in this case, our theta, we're going to have to actually do 360 minus that 53 degrees. So then our principal angle is 307 degrees. Sorry, 307 degrees. The principal. Okay, so be careful there. We're going to get into another example that you don't have to do that, but just in this case, make sure that you're looking at that diagram and there's one extra little step of doing that subtraction at the end. So for example 2 here, we have point P -3/4 on the terminal arm of an angle in standard position. We're going to sketch it. Sketch our principal angle, determine the value of our related acute angle, and then figure out what the measure of theta is to the nearest degree. So first you can sketch it here. You have your point -3/4, just using your Cartesian grid, and then you are able to further connect that and label it with the 4, the 3, and beta. We're going to keep that negative sign out here. The reason being, when we're going to use our trig ratios, if we use only positives, we're actually going to get our positive related acute angle rather than in our last example where we got a -53 degrees because we used our negative sign down here. So we're just going to keep them positive. That's okay. You're still using the correct values, and it will just give us a positive related acute angle. The easiest thing, though it will help you, is to be able to draw the Cartesian grid and label it like we have. If not, it might be more confusing for you, okay? So here, do we have our r yet? We have our y, we have our x, but we don't have our r. Do we need our r? Well, no, because we are able to use either sine, cosine, or tan, while we have our opposite from beta and we have our adjacent from beta. So why don't we just use our tan ratio? And you can fill that information in. So you have your opposite, which is 4, and your adjacent, which is 3, and then you're able to take the inverse of that and you get approximately 53 degrees. So you have solved for beta is 53 degrees. If you were to keep that negative sign, you're not wrong, but you're actually going to get an angle down here, and you would see that this would be your 53 degrees here. So that's okay. You just have to realize that if you kept that that angle of tan, sorry, I should have written tan. If you kept tan theta -4/3, you would have gotten -53 degrees. It just means that you need to transfer it up into this triangle, knowing that this related acute is equal to this related acute. Okay, so you can either keep the negative from the beginning, like in this, or just take the negative out and it just is one less step. Okay, and then we're figuring out what the measure of theta is to the nearest degree. Since we are in our second quadrant, you are going to take that 180 and then minus our beta, which is -53, so 127 degrees. So therefore, theta is equal to 127 degrees. Okay, so a little bit different this time just because we took away that negative, but you can do it either or. You just need to realize that that -53 doesn't make sense down here. It's not even in the triangle you're talking about, so you need to transfer it up to be where that angle beta is for your related acute angle. Okay, so now sometimes rather than using those points and stuff, we're actually going to work with our exact values for our trig functions, and these are in our unit circle. Okay, this does look a little confusing at the beginning, but I'm going to teach you a way to memorize this, so just bear with me for the next couple of slides, and then it will make a little bit more sense. Okay, So you always are going to have your point x comma y, which is actually cos comma sine. Okay, so looking here, if you have your 30-degree angle, your related acute 30 degrees, you know that your sine, is going to be, your cos is going to be root 3 over 2, and your sine is 1 all over 2. Okay, gets even more confusing. Look at, we now have our, we now have our 45-degree angle. Remember, we're working with our special triangle, so we're going to look at 30 degrees, 45 degrees, and 60 degrees in each of these quadrants. So your cosine is root 2 over 2, your sine is root 2 over 2 for that, using your special triangles. However, we can actually go around in our whole unit circle and look at 30, 45, 60, 90, 120, 135, 150, 180, which, remember, 150 would be a related acute of 30, the 135 would be 45, 120 would be a 60. So you just are doing the principal angle for those. Okay, you look at -1 and 0 at 180 degrees, again in your third quadrant and again in your fourth quadrant, which looks insane and crazy, and I don't expect you to memorize it like this. I will show you a much, much easier way. Okay, so some examples. So you're going to find the cos of 150. So you're going to draw that 150 degrees, and then from that previous example, you would know that 150 is there, and then that is actually negative root 3 over 2, comma pi over 2. So if I actually go backwards, that's exactly what was there. It's the exact same diagram. So you should know that it's root 3 over 2 because I'm looking at the cos. Cos is first, and it's also negative. Okay, so exactly for tan, so you're looking at negative 45 degrees here. So you're looking, you go down negative 45. You're looking at the tan, so it would be cos divided by sine, and you're going to get negative root 2 over 2 divided by root 2 over 2. When you do that math, it's actually just negative 1. Find the exact values of 225. So draw your 225. Your related acute would be 45 degrees there, and then you're going sine, so it's going to be negative root 2 over 2. Again, 180 from that previous sketch is negative 1, 0. Remember that it is between your, or it's laying on your x-axis, so it's going to be 0. It can't be negative 1 or anything. Okay. But again, here, how do we remember these coordinates? I just went through that really fast because I never will expect you to remember it in that way. Okay, there is this much, 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 much easier way to remember it. So I would recommend practicing this and writing it down every time you're doing your homework, and even on different pages. And I'll teach you the really easy way to remember. So you're just going to go 0, 30, 45, 60, 90. Up, those are all of our nice angles that we want to know. Okay, and then watch this pattern. All of these are all over 2. Every single one is a denominator of 2. So you can write 5 and then another 5 denominators of 2. Then you're going to do root of 0, root 1, root 2, root 3, root 4. Then go backwards. Root 4, root 3, root 2, root 1, 0. Easy enough? Okay, however, some of these you're going to want to simplify. This is 0. Root, the square root of 4 is 2, all over 2. So this is actually just 1. Same with this one here. And this one is also 0. Okay, so some of those you'll actually want to simplify so they're a little bit nicer. Sine will always go on the top and cosine on the bottom there. Okay, so this is key to memorize and to be able to use. It just makes your life a lot easier, and you don't have to write out all of your special triangles every time you go to use them. Okay, so we're going to get into some examples here. You'll notice I have copied this down, but you would want to have this copied down for your homework or for questions that you're doing. Okay, so I'm asking you to solve for theta. So we're solving sine theta equals -1 all over the square root of 2. Here are your steps. We're going to go through lots of examples right here. So here are your steps for these. First, we're going to determine our related acute angle. We're going to place our related acute angle in the two quadrants that agree with our sign, or so our cast rule. So if it's negative, you're going to have two quadrants that sign would be negative in. If it's positive, you'd have two quadrants sign is positive in. Okay, that'll make more sense in a second. And then we're going to determine our principal angles. So first, remember, we don't like this net root 2 on the bottom, so we're just going to rationalize our denominator by multiplying the top and the bottom by the root of 2. So we're going to get negative root 2 all over 2. So that is what we're looking for. However, come down here. Where is sine of root 2 over 2? Our related acute angle is going to be 45 degrees here, just simply based off of this is 45 degrees. Okay, and then using our cast rule, sorry, that kind of came up on that triangle. Using our cast rule, we need it to be negative. So where is sine negative? We have sine is negative in our tan quadrant and in our cosine quadrant. Okay, so you're actually able to draw those two arrows there, and you know that this is going to be 45 degrees. It would also be 45 degrees over here. Then you're going to, so we've placed our two related acute angles with the quadrants that agree with our sine or our cast rule, and now we're determining those principal angles. So our first one is that first one, which would be 225 degrees, and then you have to also go around, again, let me go in here, and that would be 315 degrees. Another way to figure those out, you're going to go 180 plus the 45 for that one in that third quadrant, which is 225, and the other one would be 360 degrees minus that 45 degrees is the easiest way to do that one to get 315 degrees. So there's your two principal angles for the sine theta of negative root 2 over 2. Okay. Again, lots of examples we'll go through, so don't worry too much about if it's super confusing right now. Okay. For our second example here, we're going to follow the exact same summary steps by determining our related acute angle, placing the related acute angle in the two quadrants that agree with the sign, and then we're going to determine our principal angles. So again, I've copied this chart down here. We have cos theta is positive root 3 all over 2. So come down to your cosine, and you see that it is at 30 degrees. Again, so you know your RAA, related acute angle, is going to be 30 degrees. So you could also figure that out from your triangle as well, but no need to if you have this memorized. Okay, so now you're going to place your related acute angle in our two quadrants that agree with our sine. So our sine is positive here, so we need where cosine is positive. So cosine is positive in our C quadrant and in our A quadrant. So you're going to draw your related acute angle in your A quadrant and your C quadrant, or quadrant 1 and 4. And then we are able to determine our principal angles. So because we're in quadrant 1, our one principal angle is going to be 30 degrees because it is our easy quadrant, and you are able to just use what the related acute angle is in that quadrant. So we have 30 degrees. Ooh. And then you're also going to have to figure out what the blue terminal arm is, and it's going to be that 360 degrees minus that 30 degrees. So you have another principal angle of 330 degrees there. Okay, so that is quite simple if you're following these 3 steps here, okay? Again, another example, we're going to look at determining our related acute angle, placing it in our two quadrants that agree with our sine, and then determining our principal angle. Here we have tan theta equals negative root 3. Okay, so we need to figure out, though, which one is going to be sine divided by cos. is equal to tan because we're looking at tan here. So if you're looking at sine divided by cos, will any of these, when you divide them, equal to root 3? Don't worry about the negative, just worry about that root 3. So looking here, if you can see any of them, I'm not sure if you can. Might be a little hard, so I'm going to show you something after. It's actually going to be this 60 degrees because these twos essentially are going to cancel out, and then you have root 3 all over root 1, which is just 1. Okay, so another way of figuring it out is to know that your root 3 is in your special triangle with your 30 and your 60 degrees, and you know that opposite and adjacent is your tan ratio, and that's your 60 degrees. So root 3 all over 1 is going to be your 60 degree related acute angle. So you know your related acute angle is going to be 60 degrees. So you either need to be able to do that double fraction division with sine divided by cos and see that, or just draw your special triangle and then it will help you with that as well. Okay, so we're going to figure out where negative is for tan. So we know negative is going to be in our C quadrant and our S quadrant because it can't be where it's positive, which would be the T and the A. Okay, so you're going to draw that 60 degree related acute there, and also the 60 degree related acute as well in your cosine quadrant. Okay, then you're able to use your triangle and figure out that your principal angle is 120 degrees there. Again, that's 180 minus 120, minus 60, which is equal to the 120. And you're also able to do the 360 minus that 60 to know that that last one is 300 degrees. Sorry, a little messy there. Okay, so you're finding out that principal angle. So therefore your two principal angles are 120 degrees and 300 degrees. Okay, so for this one, you are determining your related acute angle, placing the related acute angle in the two quadrants, and then determining the principal angle. So this time doesn't really look like we have much, but remember we simplified some of these. We had negative 4 over 2, which was equal to 1, and it also is equal to 1 here. Here we're looking at sine, so sine is going to be equal to 1 at 90 degrees. So you're going to label that 90 degree, oop, the arrow's the wrong way. So it's going to be at 90 degrees. But if you're looking at your sines here, sine is positive in this quadrant and sine is positive in this quadrant. Okay, so if we want negative 1, does it make sense that it can be 90 degrees if it's between two positives? Like even if we went 1 degree over, we would be in a positive sine quadrant. If we went 1 degree over here, we'd be in a positive sine quadrant. So does that make sense? No, it doesn't. So it actually can't be positive at 90 degrees. Okay, or sorry, negative at 90 degrees. So we're going to take our other one that is directly underneath, which is at 270 degrees, and that is what your principal angle is, because this is negative in this quadrant and sine is negative in this quadrant. So the only way that your sine can be negative 1 is going to be in your cosine and your tan quadrant, so it has to be at that 270 degree mark. So your only principal angle here is 270 degrees. It's not that 90 degrees, okay? So a little confusing. Before, all of our examples had 2 answers. We had like 2 quadrants that they could all fit in, but sometimes you're only going to get 1 answer, okay? So just be careful with that. We're going to go through another example on the next slide as well. Okay, let's look at cos theta equals 0. So here we had a 0 for sine, and here we have a 0 for cos. So we're looking at 90 degrees for our cos to be 0, and we can also be 270 degrees, and that is because we're not looking at negatives and we're not looking at positives here, okay? So it has nothing to do, because it's 0, it's going to be at 90 degrees and also 270, so we actually do have, we do have two principal angles here because you don't need to figure out positives and negatives too, okay? So positive, our principal angles would be 90 and 270 degrees. Okay, so that question is done. So for another example, we're going to determine the exact value of cos 45 times the sine of 225 plus the cos of 210. And the key here is that it is exact value, so you're going to need that chart again there or your special triangles. Okay, so let's look at each of these individually before we do any of that addition and multiplication. So cos of 45 is quite easy. You just are going to come down here. It's root 2 all over 2. You could also get that from your 45-degree special triangle. Okay, you're going to have our multiplication there, and then sine of 225. But you come down here, you don't have that 225 degree here. So remember that you're going to find the related acute angle for 225.
Kristen Laurel, call 5107. Kristen, 5107.
So to do that, you're just going to take 225 degrees and minus that 180 degrees, and you're going to get 45 degrees there. And when you do that, you can now find the sine of 45 degrees. So find it over here. It's the root 2 over 2 as well. Just be careful. Remember for these ones, because we are drawing our terminal arm at 225, and you know your related acute is here at that 45 degrees, you need to pay attention to your sine here. So because it's in our tan quadrant, we know that it actually, and it's sine, sorry, this is sine here, you know that it is going to be a negative root 2 over 2, okay? And then cos of 210 again, find that RAA for 210 degrees. You're going to do 210 minus that 180, which is equal to 30. So you're going to find the cosine of 30 degrees, which is root 3 all over 2. And then again, you're drawing that angle of 210 here. So it's pretty close to this angle here. And you're going to have that 30 degrees here. And remember, it's cosine, but we're still in our tan quadrant here. So it is also actually going to be negative. Let's put that in brackets just because we have the double sign there. Okay, so now you're going to follow BEDMAS, do our multiplication first. So you're going to do root 2 times negative root 2. So that's actually just negative 2. And then 2 times 2 on the bottom, which there is 4. And then we're going to add negative root 3 all over 2. This simplifies to negative 1 all over 2 plus negative root 3 all over 2. Since you have a common denominator, we can just go ahead and add those. And we're going to have negative 1. Let's get rid of this plus negative. It's ugly. So we're going to have it as negative, and it's root 3. And then all over 2. Remember, you don't add those denominators. It stays the same. So that is your answer there. Okay, this is kind of a wrap up for our lesson and everything we've done the last couple of lessons. So just again, looking at some of that language and making sure that you're good with remembering what like principal angle, our related acute angle, your cast rule, and all of that is. So the next couple slides are all some review for us. So find the principal angle that is coterminal to 800. Remember, coterminal means that it has to have that same terminal arm. So, and principal angle is between 0, that angle theta has to be between 0 and 360 degrees. So all you're going to do is simply take 800 and you're going to subtract increments of 360 degrees. That first one is 440, still not in between 360 degrees, so subtract again, and you're going to get 80 there. So your principal angle that is coterminal to 800 degrees is 80 degrees. Find the related acute angle of 195. So again, draw that easiest to draw. Draw the 195, which is right here. And then your related acute is in here because it's always with your x-axis. So you're going to just simply take that 195 degrees, subtract that 180 degrees, and you're going to get 15 degrees there. So your RAA for 195 degrees is 15 degrees. For our next example, we're going to find theta between 0 and 360 degrees. So if cos theta equals cos 130 degrees, we know that we are able to draw that cos 130 degrees. So draw it over here. So you know that it's 130 degrees. And then you're able to find your related acute angle. So let's go RAA up here. 180 minus that 130, which is equal to 50. So you know your RAA is 50 degrees. And then you know that from drawing this, your cosine is going to be negative in this quadrant. We're looking at cosine here, but it's negative. So we already know that the one angle theta is 130. So we also need to find the other quadrant that it's negative in, which is your tan quadrant. And you're going to draw that same 50 degrees here. And then you're going to find your principal angle that goes from the first quadrant all the way to that other terminal arm. So you're going to do 180 degrees plus that related acute angle of 50 degrees to be 230 degrees. So you know for this example that theta is equal to 230 degrees. For this next one, again, same steps. I'll change colors. You are going to draw your 250 degrees, so it's going to be somewhere around here. You are going to find your related acute angle, so do 250 minus the 180. Oops. And that's going to give you 70 degrees. And then you're going to use your cast rule. You know that sine is negative in this quadrant, so you're going to find where else it's negative, which is over here. So you have your related acute, of 70 here and then 70 here as well. So then to find that angle, you're going to go 360 minus that 70 degrees, so it's 290. So theta in this example is going to be equal to 290 degrees. This last one, same thing. You just have a negative angle. Doesn't change anything though. So draw your negative 140 degrees here. Find your related acute by doing 180 degrees minus that 140. So it's going to give you a related acute of 40 degrees here. You're looking at positive tan. So tan is positive in this quadrant, so it is also going to be positive here, and it's 40 degrees here. So then theta is just going to equal 40. That's your easy quadrant. You don't have to do any math there. It's just the angle that you see. Okay. Another type of example is finding the exact value. As soon as you see that exact value, you know that you need to use your chart that you have memorized. So your first step is going to be to find your related acute angle. So 225 degrees, draw that out. And then you're going to do 225 minus that 180 degrees there, and you get a related acute of 45. So we're going to find the sine of 45 degrees. Sine of 45 is that root 2 all over 2. What quadrant is it in though? C-A-S-T. It is in our tan quadrant, so you know that the answer must be negative. Okay, same step here again. Draw your 330 degrees, which is there. Find your related acute doing 360 minus the 330. So your related acute is 30 degrees. Find where cos is equal to 30 degrees, root 3 all over 2. Double check your sign, see it's in your positive cosine quadrant, so you know that your answer is going to be positive. Okay, see here you have cos is 180 degrees. So again, draw this, and you know that 180 degrees is over here. So you know it's going to be a value of 1 because it's on that x-axis over at 1. However, you need to figure out the sign of it. So you're going to again look at your quadrants and your cast rule. Here, cosine would be negative in your sine and your tan quadrant, but positive over here. But since we're looking at it over here, you need to realize it's going to be a negative, because even if you went 1 degree off of the 180 degrees, either way, it's going to become in a negative quadrant. So your answer is actually going to be negative there. Okay. Next example, again, using your chart is going to be the easiest. You could use special triangles though. So for this one, you are going to find where sine theta is equal to root 3 over 2. So sine root 3 over 2, it is 60 degrees. So you need positive as well. So see where sine is positive. So it's going to be in your first quadrant and in your second quadrant. Since it's in your first quadrant, it's going to be 60 degrees, but you need to find that principal angle over here. So you're going to have to do 180 minus 60 degrees, which gives you that 120. Okay, so another theta is going to be 120 degrees for that example. For that next example, you are looking at cos of 1 over root 2, which you know is the same as root 2 over 2, just with the denominator rationalized. So it's going to be at 45 degrees. So draw using your cast rule where cosine would be negative and then with a related acute of 45. So it's not going to be in these two quadrants. It's going to be here, so 45 degrees here, and in your tan quadrant as well. So you're going to find that principal angle and this principal angle. So you're going to do 180 minus the 45 and also 180 plus 45, which gives you the 135 and 225 here. So theta is equal to 135 and theta is equal to 225. Okay, for tan, theta equals -1. You know that you're looking for what two of your ratios or fractions here when they divide, so sine divided by cos, because remember that is sine theta divided by cos theta. Which ones, excuse me, which ones give you 1? Don't worry about that negative yet. And it is going to be this 45 degrees, root 2 over 2 divided by root 2 over 2 is going to give you 1. So you know, again, it is going to be 45 degrees. We're looking at tan, though, and where it's negative. So tan is negative in your second quadrant, so 45 degrees here, and in your cosine quadrant, again, find your two angles, and it is going to be 45 degrees plus the 180. Subtract 180, which is 135 degrees, and then 360 degrees minus that 45 degrees to give you 315 degrees. So then theta equals 135 and theta equals 315. Okay, and then here we're looking for where sine is equal to 1. So if you follow along here, sine is equal to 1 at 90 degrees. Remember, the square root of 4 is 2. 2 divided by 2 is 1. So then simply just are going to put 90 degrees there. Okay, so you are done. You get to start your homework. Good luck. Let me know if you have any questions.